Okay. So we're on the 7th graph, yes?
Yes, sir. The Limacon.
Limacon. What is the equation that they give you to study?
A plus B cosine theta A minus B.
A plus or minus B cosine theta. And they probably gave you a condition.
A must be greater than B.
A is greater than B. All right, so get to work. Take the calculator out. Try some scenarios where we have a number plus another number, cosine theta, specifically where A is bigger. So something like 2 plus 4 cosine theta.
You mean
2 minus 3. Or I'm sorry, I did it backwards. 4 plus 2 cosine theta. 3 minus 1 cosine theta. We just want A to be bigger, right? So in a minute, I'm going to pick someone. And the goal is for you to describe to me, without saying put it on the calculator, describe to me what 4 minus 2 cosine theta is going to look like. Give me some main points and stuff like that. So 30 more seconds.
Go to window. Yeah. Theta min. 0, 2, 5. That's fine. Negative 9.4. No. 6.2. 6.2. Polar. Negative 6. Okay, so now you should be able to just kind of play around like they're doing and just look at the picture. That's all we're doing. Yeah, but you don't need it. You really don't. Change your mode. Who else was gone yesterday? If you're gone yesterday, listen to me very carefully so that you can follow along with what we're doing today. Go to mode. Change your graphing calculator to polar. Now go to window. You should be at, and also, sorry, go back to mode and make sure you're in radian if you're not in radians. Okay, once you do that, go to window. Your theta min should be 0. Your theta max should be 6.28, blah, blah, blah. If it's not, just type in 2 pi. Okay. Your x min should be negative 9.4. Your x max should be 9.4. X min is negative. X max is positive. I know it's backwards. Because the minimum has to be small, right? The y min is negative 6.2. The y max is 6.2. Your theta step, if it's not 0.1 something or other, type in pi divided by 24.
What was theta max?
2 pi. You were here yesterday. You weren't here yesterday? Okay. Never. Oh, you were doing the testing too. Okay. All right. So, anybody have what this is kind of going to look like? Erica.
Okay.
So here I am. I'm at the pole.
Yes.
Tell me what to do.
Okay, so one of your points will be at like on the x-axis on -2, and the other one that's on the x-axis will be 6, isn't it? So you like
6 which way?
6. Okay. So the first point, make a point at like -2.
Here?
Yeah.
Are you sure?
-0, yes. But this is what the other. This is what I got. Is this what it's supposed to look like?
Did you do plus or minus?
I did plus. Oh. So it's basically the same.
Basically the same, just flip
Okay.
over what you were telling me.
Yeah. Okay. Sorry. So you're gonna have a point at -6, 0.
Over here?
Yes. And
Okay.
then your other point that's on the x-axis will be at 2.
Over here?
Yes.
Okay.
And then you'll have a point that's at 0, 4,
Uh-huh.
and then 0, -4.
Good.
And then you just connect it. And the point, is it supposed to look like a kind of smush?
Yeah, it's like a smushed heart.
Heart?
Or, I mean, it kind of looks like this.
It looks like a circle. Yeah, it looks like a circle, but it's like smushed.
Depending
together.
on what values you use, you might actually see what kind of looks like a lima bean or like a cardioid.
That's
but-
why they call it a
Okay.
What was the equation she said?
Right here.
Oh, 4 minus 2.
Okay. So, recap. Let's see where we can get these points from looking at the equation. So for those of you that were gone yesterday, pay attention because a lot of the themes that we're going to talk about is what we learned yesterday. Minus cosine means that your main direction is left. Okay? What do we do with the 4 and the 2? Add them. So our main direction, we're going to go left 6. There's a point. Okay? This first number tells you the width of the shape. Does that make sense? So up 4, down 4. Now, kind of a coincidence, because you could argue, oh, this 2 means, and I didn't label that. That was a 2, right? This 2 means that we're going to go 2 to the right. It's actually not because this is a 2. It's because the difference, the difference of 4 and 2 is 2, so that's how we know we go over there. So let's try one more. Let's say we have r equals 2 plus just 1 cosine theta. Okay? So yeah, it's going to be a little smaller. Main direction, left or right?
Right.
Good. How many units?
3.
You always add, right? 2 and 1 make 3. The first number tells you the width.
Sure.
So 2, -2. And now the difference between 2 and 1 is 1. So that means that we should have another point over here that's 1 unit back. Okay, so let me just quickly confirm. You can type it in 2. That's exactly what we talked about. 3 to the right, 2 up, 2 down, and 1 back. Okay, so we have something that looks kind of like this. Paulina.
So even if it's addition, it will subtract them?
Yes. So this is a great question. The plus and the minus that you see in these really just mean direction. So I wouldn't think like, oh, it's a positive 2 and a negative. It's just 2 and 1. Difference is 1, right? It's just 4 and 2. Difference is 2. The minus and the plus just tell us we're on the right side or we're on the left side. Does that make sense? Okay. Now, if I'm not mistaken, the next one is the same idea except sine. So a plus or minus b sine theta. And for those of you that were gone yesterday, who was here yesterday that can tell us what's going to happen? Because we already know, don't we? Abby?
So like it's like right now close vertically.
Perfect. So cosine gave us a clue as to whether we're on the right or left side, right? And sine is going to be vertical, either up or down, depending on whether it's positive sign or negative sign. Okay? So let's do one example. 5 minus 3 sine theta. We don't have to play around with this anymore because it's the same shape, just different direction. Okay. Main direction is which way? Down. How much? 8. You always just add them up.
Oh no.
You're thinking for the next part. The first number tells us the width, so we're going to go 5 each way. And now the difference tells us this other little secondary point, 2. So it should look roughly something like that. Is that what you guys are getting?
Is it supposed to dip?
Sometimes they do, yeah. I'm not going to be picky about whether you do that or not. Okay. The goal is on the quiz, it's all no calculator, so you're going to see a bunch of these graphs and you're just going to have to know how to do it. Okay.
Okay, so you did 5 minus 3, and that's how you get the 2.
Yes,
So
it's the difference.
So for the other one, like when it was 4 minus 2, that's why it was 2.
Yes.
And it's 2 plus 3.
Yes. Anything else? So are we good with 7 and 8 here? Okay. What are you handing out? Cheese? Oh, flatbread. All right. No. Number 9. Is it the cosine or the sine one? So r squared equals a squared cosine 2 theta, right? All right. In order to type this in the calculator, so you guys see what's going to happen, we do have to square root this one. Okay? So we're going to have r equals, what's that? R equals plus or minus square root of a squared cosine 2 theta. So on your graphing calculators, if you're going to play around with a number and look at a graph, you should be typing in 2 graphs, right? One with the positive square root, one with the negative square root. And if I were you, I'd pick a nice square number here. Like I wouldn't put in 3.
4.
Okay, 4 would be a good number to try because then a would be what? 2. We want to see the connection there, right? 9 would be a good number to try. 16, 25. Yes?
So like for a graph like this on the test, you're not going to give us some crazy number.
No. Well, once we know the relationship, you could get a goofy number, and then you just approximate what it's going to be. Okay, so I'll give you a minute to kind of...
Okay.
What numbers?
I'll make this.
Like that?
That looks good. That looks good.
Got a hair.
Square.
Looks good. Yep.
Yeah.
Looks like everybody's getting it. Some of you see a graph that kind of just stops, right? Like it doesn't really connect. Are you guys seeing that? It should connect. Use your imaginations and connect it. What are you going to see?
Oh!
Oh my God.
Wait, suppose
So what shape did we get? Yeah, it actually, it's like an infinity sign or a figure 8.
Mr. G, mine's there.
Mr. G. Don't you wear a Hawaiian themed shirt every Thursday?
Go to. That should be a negative.
Okay. So what are we seeing here?
Does it connect afterwards?
It does. It's just your calculator has a hard time doing that because of the settings that it's on. So it does connect. So, what if I had then, the original problem was r squared equals 25 cosine 2 theta. Who can raise their hand and tell me what this is going to look like. Besides Eric, I've heard from her. Ryan. For those who can't see, he did that. Okay, how far do I go?
Go 5.
5. So 5 this way,
Yeah,
5 that way. And you just kind of do one of these.
Yeah.
That's it?
Wait,
Yes.
you don't necessarily know like how much, like on the curve, like you don't know, like I don't know, like for the graph, like you wouldn't know, like for the y-axis where it would go.
Like
it
how
goes
far
to the
up?
Origin, and like it goes to the origin, it goes through like 5 and -5, you know that, but like you know like that curve part.
How far to
you
make?
Yeah.
Yeah, that's an approximation. That's fine. Yeah. All we care about, so when you guys get your quiz or your test, as long as I see these 3 points, pull 5 to the right, 5 to the left, and you connect with the figure 8, you're good. Okay? Any questions on graph number 9? Go to number 10, and let's see if you can figure out what's going to happen there. And before you tell me what you think, double check.
Uh-oh.
Whoa.
Did it do what you thought it was going to do? Yeah, this one's kind of strange. So now the next question is, all right, so now you tried one. What if you mess with the numbers? It's still going to be kind of in the same spot? Or is it going to start rotating at all, or is it really just on that same angle?
It gets bigger.
So it just gets bigger? Okay. So if I have r squared equals 16 sine 2 theta, the 16, just like the 25, told me to go out 5, right? The 16 is going to tell me to go out 4, but now where? It's right around, centered around the pi over 4 angle. Okay? So that's just in the middle of the first quadrant, middle of the third quadrant. Make a point here, and then you said out 4, right? So I don't have the circles, but I'll count 4 units out, 4 units out, and it's the same shape, right?
Is it always pi over 4?
Well, that's what I asked, and you guys said yes. So I'm going to believe you. Paulina.
You're going to believe us.
Never mind.
Okay.
You're going to believe Austin.
But you're the math teacher.
Yes, it's always fun.
Okay.
You're going to believe Kevin?
I was busy playing around with the numbers.
Okay. Whoa. Did you type in the square root, or did you just do r equals 16 sine 2 theta? Okay, so hold that thought. There's 2 more graphs, right? 11 and 12, what are they called? Rows, okay. So I'm guessing the first one is a cosine rows, right? So, this is 11. So it's going to be r equals some number, right? Cosine, did they use n?
Yes.
N theta. So this equation looks almost the same as those circles that we did yesterday that were like on the right side or on the left side, except now we have something besides 1 in front of theta. So 2 theta, 3 theta, 4 theta. So what I want you to do, play around with A, play around with N, see if you can come up with what's going to happen. Okay? And there, I can tell you right now, there's going to be 2 scenarios, 2 cases.
Oh, yay. Whoa, yay. What'd you say?
Alright, so 4 cosine.
Oh, I got 3.
What's the limit on how much you're gonna make a super like pedals? I guess you're gonna get.
Oh!
Okay.
Oh.
If you put 6, okay. If you put 6 in the cosine, there's I think 12.
So if you put a 6 for n, you said you get 12 petals?
You get 12 pedals.
Okay.
What is this?
Oh, that's insane.
So
That's
that's
so pretty. Look at it. Pretty. Wait, so what happens?
then when you put 5,
Wait, no. Wait,
it's still 5 pedals.
When it's 5, it's 5, but when it's 6, it's 12.
Wait, but I just
Hold
made a
on.
circle.
Hold on.
I just made a circle.
Did you use n equals 1?
Oh my god.
Odds
No.
don't stay the same. I mean, odds do the same.
You put cosine.
Oh, I didn't put
Oh, yeah, you need a theta in there.
Wait, is it because I don't know why, but
Hey,
it's
look.
something to do with parameters.
Not sure it's that involved. Does anybody have what the two scenarios are going to be yet? So when it's even, all right, Ashley, if it's even, how many petals are you going to see?
Like double the amount.
Double the amount. Let's write it down. So number of petals equals 2n, double the amount, right? And then you also said if n is odd, how many petals? The same number, very good. So very important to remember. If n is even, double the amount of petals. If n is odd, then that's just the number of petals you got. Next question. Where do we start? So do you guys see anything in common? Where do they all go through? Well, yeah, they're going to go through the origin, but like I'm talking about an angle, like 0, pi over 6, pi over 3, pi over pi over... Is there one that's always on the graph?
There's one. There's always going to be one, at least what I got from the odd one. One petal that's there's a line of symmetry going right through the x-axis.
To the which side?
On the positive
On
side.
the positive side. So positive x-axis, what angle is that?
0.
0. So we have someone that confirms when n is odd that we're going to start at 0 degrees for our first petal. What about when n is even?
Same thing, but
Is it the same? Someone want to confirm that?
it's like
Well, let's try an example. 3 cosine 4 theta. Let's see. So, looks like we still have 1 at 0, right?
Can you try 9 to 6?
Still looks like we have 1 at 0, right? So why don't we just say, no matter what case it is, we're going to start at 0. Okay, 0 radians or 0 degrees, whatever you want to say. All right, so then next question. How far out do we go?
However many A's.
So if it's 4, you just go 4 out for each one?
Yeah.
Okay. So A is the amount that we go out for both cases. So we got number of petals, double for even. Always starting at 0, go out A. If n is odd, then n is the number of petals. Still going to start at 0. Still going to go out A. Last thing, spacing. We don't just randomly put in 4 or 5 petals. We got to be as precise as we can be. How do I space them out? Because, if I'm looking at this, it looks like everything's pretty evenly spaced out, right? What if it was odd?
by 2 pi by the amount of petals.
So let's do degree. Is it better to use degrees for this, maybe? Because, I mean, we're not always going to have nice radius. Like, what if it was 5?
Well, I mean, if n's the for odds, if n's the number of petals, then you divide 2 pi by 3, and then every 2 pi, and then kind of repeats.
So then we're going to space out 2 pi over 3, which makes sense. But what if we have, like, 5 petals? Then we have to space around 2 pi over 5. Let's do degrees. Spacing. 360 degrees. What do we divide by?
By n.
5 for each.
And 2n's.
Well, for even, it's 2n. Let's just write number of petals. How about that? So no matter what case we're looking at, we just take 360 divided by the number of petals, and then we're good. All right? So now, when do we get out of here? 17? Okay. Let me just cruise through this. So here's an example. R equals 5 cosine. Let's do an odd one to start. 3 theta. Here's what I would expect you to do on your quiz or test. Tell me first that there's 3 petals. And really it's the spacing, right? What's the spacing?
120.
360 divided by 3 petals. So that's 120 degrees. Where do we start? At 0. So if I'm going to start at 0, and I heard Nate say 5 like 8 times. So Nate, how far out am I going to go?
5.
There we go. And now according to the spacing, I should go from 0 over to 120 degrees. For you, that should be the first, the one next to 90, I think, on your sheet. Yeah? Because you have 3 lines, right? Okay. I don't have one, so I'm just going to estimate that this is 120. And then we go out 5 there as well. And then the next one would be 240, so just right below it, right? Out 5 as well. And then that's it. So draw 3 petals. Should look something like that. What's that? No, I mean, but it should look something similar to this.
Instead of 3, you put -6 and makes it a circle.
-6 makes it a circle? 96? No, it's just too many petals in the calculator doesn't show them. It just shows the, trust me, sign.
It ends at 4 or something.
Okay, real quick. If we have, let's say, 2 sine, let's do 4 theta. Oh, I didn't want to do sine yet, sorry. We're still on cosine. So, how many petals here? 8 petals. Spacing would be what? 360 over 8. Because there's 8 petals. What is that?
45.
45. And we're still going to start at 0, right? So this one's pretty easy. You're going to have a lot of petals to draw, but we go out how far each time? 2 out at 0, 2 out at 45, 2 out at 90, 2 out at 180, and then, what is that? 225, 270, 315. Can someone close the door so we can finish up the last one? And then you should have something that looks kind of like this. Those petals do not overlap, so do your best to just, I know I kind of messed mine up there. If you need to make them a little skinnier, that's fine. They don't intersect themselves out here. They just all meet at the origin.
What was the equation?
Yes.
So how'd you get 8 petals again?
4, double it.
Oh.
Any questions on how I got that? Okay, last rows is the sine rows. I'm just going to go through it since we're almost out of time. R equals A sine n theta. Okay? Rules are the same. If n is even, number of petals, 2n. Spacing, is still going to be 360 over the number of petals. If n is odd, number of petals, still n, and spacing, still 360 over the number of petals. Here's what changes now. The A is still going to tell you how far out to go. The thing that changes with sign is where we start. And where we start is always 90 degrees divided by whatever this n number is for both.
Just n, or even is it 2?
No matter if it's even or odd, it's just going to be n. Okay? So, for example, let's say I did r equals 4 sine 3 theta. How many petals? 3. Starting at 90 over 3, which is 30 degrees. Spacing,
120.
360 over number of petals, so 120. So then, very good. So what it's going to look like, we go to 30 degrees, which for you is the first one, right, in the first quadrant. We go out 4. Here's 30. So what's the next angle I'm going to use? 150. It should be symmetrical with y. Okay? Go out 4. What's the next one? 270. Go out 4. And if you draw it, you're going to see that we have y-axis symmetry. And that's a good way to check to make sure that you started in the right spot. And that's what it would look like if it were an odd sine rose. Even works the same. We just have to figure out how many petals there are, find all the details. I think, does this kind of make sense?
Yeah.
Okay. Do your homework tonight, practice, so that tomorrow when we do our little game, you guys can actually have some fun and compete and make things interesting.
Wait, what's the homework?
Day 11.
Wait, day 11 was like 10.6 in the packet.
Was it?
Yeah.